Hello, we're going to work on some frequently asked questions about this set of problems. So, first, number 11. It looks like this and question 10 are really challenging problems. What you'll need to use is a change of base formula and some tricky factoring probably. But if you say take the natural log of each side, natural log of e to the x plus 1 equals natural log of 10 to the 2x, then we can have something that says x plus 1 equals natural log, we can do 2x natural log of 10. And that way we get something along the lines of, let me get a highlighter here. And there's highlighters. A value, a power on e times 2x. So altogether, the 2 and the natural log 10 are a coefficient on x. And then x plus 1 is, of course, a linear function. So if we're looking at our answer here, 0.28, then let's see if we get something that makes sense and something that we can actually solve for. Let's see, so I guess we'll just subtract x from each side. So we'll get 1 equals, we'll say 2 natural log 10 times x minus x. And what do we have? What do we have here? We can factor out our x. So 1 equals x 2 natural log 10 minus 1. So if you compute this by dividing 1 by 2 natural log 10 minus 1, we should get the value in our answers. On 13 is a quadratic in form. You must make u equal to, and I'll zoom in a little bit actually. You must make u equal to e to the x. So we get something like u squared minus 4u plus 3 equals 0. And you can solve this by writing its, let me move this here, by writing its factored form. So u minus 3, u minus 1 equals 0. So that must mean e to the x minus 3 equals 0. And so does e minus 1, e to the x minus 1 equals 0. And then we ought to be able to solve for e to the x equals 3, e to the x equals 1. So natural log 1 and natural log 3 have to be our values that work for those powers. If I can scroll here. Yeah. Yeah, 21 and 23. Condense these first before you can use the one-to-one property for logarithms. So for example, on 21, you'll have x plus 4 times, 1 over x, which is divided by x. So this logarithm is now set equal to the other logarithm. And once condensed, you can solve this rational expression, rational equation. X plus 4 equals, sorry for the sloppy writing, equals 4x. So 3x equals 4, and 4/3 equals x. Let's see if we got that one. Yeah, 4/3. So similarly, you can solve 23 the same way. On 31, though, it seems like you don't have enough information to do this one, but in reality, half-life of iodine would mean we have half of the amount of iodine left over after we've started with a whole. So we can actually take this as a percentage, 0.5, 50% after we've started with one whole for our A and A sub 0 amounts. E is Euler's number, and then K is actually what we're solving for. And we actually know the time in days, 8. So from here, this should be enough information to get us to an answer. Our fun calculation at the beginning of this is divide each side by 1, and 0.5 still remains. K times 8. And natural log 0.5 equals K times 8. Natural log 0.5 divided by 8 will get you to the value you need. So we can find our K value for our decay value, really. I don't think they meant that joke. Decay value for K is going to be natural log 0.5 divided by 8. And then you can see that decimal approximation below. But what B now asks us to do is, now that we have found this K value, which I'll just leave right here, let's say we want this to decay to 10% instead of half. It's a very simple setup. 0.1 equals 1 times e to our k times we don't know. So now instead of solving for k, which we already know because of this calculation, we will be solving for t. How many days will it take? A similar situation happens for 33, the half-life of aspirin. How long will it take for the amount to be, for the aspirin to be 7%? Let me make sure I'm in the right spot here. To decay to 7% of the original dosage. Yeah. So write what you know. Write the amount that you want from the whole times e to the 12 Oh, I guess we'll have to go through, because we don't have the K value here. I guess we'll have to go through and calculate my mistake. We'll have to go through, we'll save this for later. Because we know what that is. We'll have to save the 0.7 calculation for later. My mistake. But we'll know that we have half after 12 hours. Let's calculate our k. So we'll have to go get our k from knowing that it takes 12 hours to get half. And so we'll use this k value after it's solved for. We'll have to figure out t yet again. T is something we don't know, so I'm going to put it in red. We want 70%. 1 times e, 0.7. That's what we're aiming for, the amount we're looking for. So we can go for that amount and figure out the time. Yeah, so that would be most of our issues on there. Those are some pretty big questions. Yeah, 31 is a very leading question, with 33 making you work for it a little bit. But I hope that clears up some of the confusion, and I'll speak to you soon. Bye.